You don't have to break your head about raising and first sight. To you, both mean the same. Likewise, to you, these terms mean the same. Okay. Now, guys, please remember that for an object to be visible to you, first and foremost requirement is it must be above your horizon. See horizon of the observer. Why? Because the earth is a sphere. Its surface is curved. Now, what happens to sun at night when we stop seeing the sun? Is it that the sun has switched itself off? No, the sun has not switched itself off. Sun goes below your horizon and you're not able to see the sun. So first and foremost is to be able to see an object. The object must be above your horizon. If the object is not above your horizon, however bright it may be, like sun is so bright, but at night it is not visible to you because it has gone below your horizon. So the first requirement which must be fulfilled for an object to be visible to you is that it must be above your sea horizon. Now you see, guys, the earth is curved like this. Okay. Now, if there are two observers, one observer is height O1, another observer is O2. How far can, if an object is at the sea level, for how far can the observer one see? The observer can see up to this point where you can draw a tangent from here to the Earth's surface. The observer can see only up to this distance. Up to what range can observer 2 see an object which is at the sea level? You draw a tangent from O2 and this observer can see somewhere up to this place. I'm sure there is absolutely no doubt when you have to see somebody, whether somebody is coming or not, or if your mom says just go and see if the moon is out or not, what do? You go to your terrace, you go to a higher point. Why? Because your horizon increases with the height. So observer 1 has lesser height, his range of sea horizon is less. Observer 2 has greater height, his range of sea horizon is more. So the sea horizon depends one on observer's height, and observer's height in chart work we represent or we call it as height of eye. Now this is, so do you all agree that observer's sea horizon is a function of height of eye? Yes or no, guys? Am I clear? Observer's sea horizon is a function of height of eye. Observer's height, yes or no, beta?
Yes, sir.
Correct. Now, if I fix the observer's height, then can he only see up to that horizon? What is based on his height? Now let's see. Go back to this diagram again. If the observer is here, O, his range of sea horizon, a tangent line goes like this. This is the line of sight in which he can see. Now, if the object is at sea level, he can see up to this point. But if there is an object this high here, then he will be able to see, because you see when he sees like straight, he is able to see this object. If the object is even higher, then he can see it if the object is far further away from it. So what happens? The distance at which an object can be seen by the observer because of the horizon will depend on height of eye of the observer and height of object. Am I right, guys? Yes or no? Whereas this object can be seen by this observer, but this object cannot be seen because this is below his line of sight, below his horizon. He cannot. So object X can be seen by observer O. Object Y is closer to the observer, but observer cannot see object Y. Do you agree with me, guys? Yes or no? Correct? Correct, guys?
Yes, sir.
So what decides the distance? Distance is this is the range of C horizon of the observer. This is the range of C horizon of the object. And if the sum total of these two range of C horizon, the object lies within this, it will be visible to the, it will be above the observer's C horizon. So that means range of C horizon will be sum total of range of C horizon of the observer and range of C horizon of the object. Range of C horizon of the object depends on height of eye of the observer, and range of C horizon of the object depends on height of the object. And this distance at which it can be seen or it comes above the observer's horizon, this range is called as geographical range. Geographical range is the range at which the object will come within the C horizon of the observer. It will come above the observer's horizon. And this geographical range is a function of only two things, height of eye and height of object. And to calculate this geographical range, there is a simple formula. Geographical range will be equal to 2.095 under root height of eye in which units? Meters, plus 2.095 under root height of object in which units? In meters. This is the formula by using which you can get the geographical range. Now, many a times I've seen people making this mistake. People in a hurry, they do like this. Don't do this, it's wrong. These two are not same. Please don't do that. There are stray cases I've come across where people have made this mistake. So please don't do that. Geographical range will be equal to 2.095 under root height of eye in meters and 2.095 under root height of object in meters. So let me show you this geographical range before we continue with the discussion further. And then I'll come to the remaining part of it. Under this concept, we use the maximum distance or range at which a light is first seen when you are going closer to the light and when it is last seen when you are going away from the light. Then the circle can be drawn with light as the center and the first or the last sighting range as the radius. For any object to be visible to the observer, it needs to be within the observer's geographical range and it needs to be within the observer's present luminous range, PLR. First, we are going to deal with this geographical range, and then I'll come to the second one. The geographical range is nothing but a function of height of eye and height of the observer. And geographical range is equal to 2.095 into height in meters of the eye plus 2.095 into height into square root of height of the object in meters, and you will get the geographical range in nautical mile. So this is how you'll obtain the geographical range. Now please understand, to be able to get the geographical range, what information would you need? You will need height of eye and you will need height of object. If you do not know them, you cannot calculate the geographical range. In the exams, where are you going to get the height of I from? I'll get the height of I. First, I will look for it in the question. If I don't find it in the question, I look for it in the remarks on top. If it is not present at any of these two places, then I don't have any height of I known to me. I will not make any assumptions. You will not say, can I assume it 15 feet? Can I assume it 4 meters? Can I assume it 10 meters? No assumptions to be made. So either the height of I is known or it is not known. If it is known as far as exam is concerned, on the bridge, you will have on the chart table a height of I table against the drafts. On the ship, you can find out. That's not an issue. I'm talking from exam perspective. In the exams, the height of I will be either given in the question, that is the first place you look for, or it will be given in the remarks on top. That is the second place you'll look for. And if it is not given at these two positions, that means height of I is not known to you. You cannot calculate the geographical range. Don't waste your time. Okay. Where is the height of the object going to come from? In exams, most of the time it will come from chart. It will be the charted height which will come. Now, if you have a lighthouse which is used and the height is not given in the chart, on the ship you can enter the admiralty list of lights and you can get the height. But in the exams, if it is not on the chart, then there is no way you can obtain it. Again, no assumptions to be made. If either the height of light is missing or the height of I is missing, you cannot calculate the geographical range. Just leave it there. Don't unnecessarily make any assumptions to force yourself getting some value. Am I clear about it, guys? Yes or no? Am I clear?
Yes, sir.
Okay. Now, is it that necessary that anything which is within my geographical range, I should be able to see it? Well, not necessarily. Why? I'll give you a simple example. The sun on a clear day is visible to you. Suddenly the fog sets in. Are you able to see the sun? No, you are not able to see the sun. The sun is still above your horizon. It's there in the sky, but you can't see it because the visibility of the atmosphere has deteriorated. The visibility of the intervening medium has become bad. And so, despite sun being above your horizon, you are not able to see it. So that means if an object is above my horizon, will I always see it? Not necessary. But if it is below my horizon, can I see it? No, no way you can see it then. So if the first condition of above the geographical horizon is fulfilled, still it does not mean you will see everything that is above your horizon. Guys, on a given night, if somebody holds two lamps, 100-watt bulb in his one hand and a 0-watt bulb in his another hand, and he starts walking away from you, both the lights are being carried in the same atmospheric visibility. Now, I'm sure all of you will agree that 0-watt bulb will stop being visible at a shorter distance. 100-watt bulb can be seen up to a relatively greater distance. So that means the distance at which those lights could have been seen also depend on how bright those lights are. If everything else remains same, a brighter light can be seen to a greater distance. A dimmer light will be seen to a much shorter distance. So guys, you need to be very, very clear that everything which is above your horizon does not necessarily have to be visible to you. Yes, I again repeat that if anything has gone below your horizon, no way it can be seen. That's out of question. But it does not mean that anything which is above your horizon is going to be always visible to you. Am I clear, guys? Yes or no?
Yes, sir.
Okay. The second aspect which I'm saying, that once an object is above your horizon, will it be visible to you or not will depend on two things. Number one, how bright is the object? Number two, what is the atmospheric visibility? Now, these two factors are taken into consideration in something called as present luminous range, PLR, present luminous range. So we have to get the geographical range, we have to get the PLR. Now, if we are able to get both, then obviously the object will be first seen or last seen at the lesser of the two values. Because let us say the geographical range is 20 miles, PLR is 15 miles, then obviously you at 15 miles only you will be able to see it first. But if the PLR is 25 miles, then you'll be able to see the object at 20 miles, because at 20 miles it will come above, both the conditions will be satisfied at 20 miles. It will be above the horizon and it will be within the PLR. So if both can be calculated, if both GR and PLR can be calculated, then the object will be visible at the lesser of the two. We have already learned how to calculate the GR through this formula. How do we get the PLR, guys? Now for PLR, we don't use formulae. We have a luminous range diagram. I have shared that in the initial document that I had shared for navigation, a luminous range diagram. The present luminous range of a light is the maximum distance at which light can be seen by the observer depending on the luminous intensity, that means brightness of the light, and the atmospheric visibility. Luminous intensity is covered in marine context by nominal range. So for us, the luminous intensity will be a function covered by nominal range. What is nominal range? Nominal range is the charted range of the lights. And in nominal range, what visibility is assumed? In nominal range, the visibility assumed is 10 nautical miles. So what is nominal range of a light? Nominal range of a light is the range at which a light will be seen under atmospheric visibility conditions of 10 nautical miles. It is this range which is charted on your charts. You remember when we were talking of flashing red light and we said 28 oblique or 22 oblique 18 capital M, and I said that is the nominal range. So nominal range is the charted range. Atmospheric visibility can be assessed. On ship, you can assess the atmospheric visibility at what distance a ship or object becomes visible. In examination, the visibility has to be given in the question or it has to be given in the remarks on top. In the question, in the exam, again, we will not make any assumptions of visibility. Either it is given or it is not given. Nominal range of a light is the distance at which it can be seen when the meteorological visibility is 10 nautical miles. Now, if you know the visibility and you know the nominal range, you can obtain the PLR by using the luminous range diagram. And this diagram has been shared with you guys. In this, you see, sometimes this nominal range scale may be at the bottom also, so don't get confused. And if an MMD, you get a sheet where nominal range is at the bottom x-axis, don't worry. So on the x-axis on top, you have the nominal range. Then you have these different curves for different visibilities, 0.2 mile, 0.5 mile, and up to perfect visibility. And on the y-axis, you have the PLR. This is the present luminous range. So guys, let us say if my my nominal range is 20 miles, so I go to 20 miles. If the visibility is 5 miles, I come down to 5 miles like this curve. And after hitting the 5 mile curve, I go horizontal here. And whatever I read here, this will be the PLR. So basically, to get the PLR from the luminous range diagram, I need two informations. One, what is the nominal range? And second, what is the visibility? Nominal range I can get from the chart. Visibility has to be either given in the question or it has to be given in the remarks on top. If it is not given, I cannot calculate the PLR. Is the calculation or obtaining of PLR clear? Any questions on PLR, guys?
No, sir.
So now, please remember, before we take this question, whether they use the word first sighting or they use the word raising, don't break your head. Or they use the word last sighting or they use the word dipping, don't break your head. You can see the light only when the light is within both geographical range and PLR. Now, to calculate the geographical range, guys, you need height of eye and you need height of light. To calculate the PLR, guys, you need nominal range and you need visibility. Now, if you are able to get all these four things, 1, 2, 3, 4. If you have all these four things available to you guys, please calculate both GR and PLR in your answer sheet. Once you calculate both of them, use lesser of the two because then both the conditions will be satisfied. Is that clear to everybody? If all the four things are available, calculate both GR and PLR and use lesser of the two. Am I clear, guys? Clear?
Yes, sir.
Yes, sir. Clear.
Now, because of want of information, suppose the height of eye is not given. Suppose the height of light is not given. That means now you cannot calculate GR. Or let us say the other way. Let us say the atmospheric visibility is not given. Now you cannot get the PLR. Don't make any assumptions. So now, if because of lack of information, you can calculate only one. That means GR or PLR. If you are only able to calculate one, then don't break your head. Use whichever you can calculate. Under the assumption that the other thing which you are not able to calculate is much more than that. Am I clear about? So there should not be any doubts. Sir, there was no visibility. What could have I done? If there was no height of eye, what should I do? I am sure it's absolutely clear now. If you have all the four things, height of eye, height of light, nominal range, visibility. If all the four things are there, please calculate both GR and PLR and use the lesser of the two to solve the question. If because of lack of information available, if you can calculate only one of them and not both, then use whatever you have calculated and close your question. Am I clear, guys? Is it clear now or anybody has any doubts? Bolo bhai, speak up.
Yes, sir.
Clear, sir.
Okay. So you should not be living in any doubt as to what to do, what not to do. I got stuck here. There is absolutely no way. Calculations have to be shown on the answer sheet. When we do questions, I'll keep pointing out what all needs to be put in the answer sheet. Let's look at this question. Hookhead light was first sighted at 2000 hours in atmospheric visibility of 2 nautical miles. If height of eye was 12 meters, draw the PC at 2000 hours. Guys, Hookhead light is there on the display. What is the height of the light? Can you read and tell me? Here are the characteristics.
46
What?
meter.
46 meters. You know 46 meters, you know height of eye given in the question. It is given as 12 meters. Can you calculate the GR, guys? 46 meters is the height of light. 12 meters is the height of eye. Can you calculate the GR using your calculator? 2.095 under root 12 meters plus 2.095 under root 46 meters. Can you please calculate the GR? How many nautical miles is the GR? How much is it, guys? How many meters? How many nautical miles? Sorry.
21.4.
21.5.
21.5.
Okay, 21.5 miles. Very good. Look at the characteristics on display. What is the PLR, guys, for Hookhead? Sorry, what is the NR, nominal range? My mistake, I stand corrected. What is the nominal range for Hookhead?
23.
23 miles. And what is the visibility given in the question? It is given as 2 miles. So with that, we go to the nominal range diagram, luminous range diagram. We go to 23. So your GR is 21.5 nautical miles. Then you see we go to 23 nautical miles nominal range. We go down to 2 mile visibility curve, and then we go back this side and we read off the PLR. The PLR that you read is about 6.8 or something, 6.7, 6.8. So PLR is 6.7. Now, between these two, which is the lesser one? 6.7 is the lesser one. So your light will be first seen at a distance of 6.7 nautical miles because there both the conditions will be satisfied. So with the light as center, Hookhead light as center, radius 6.7 nautical miles, you'll draw the position circle. And this is the position circle. Of course, there's no need to draw the circle on this side. On land, you can draw this position circle with Hookhead light as the center and 6.7 miles as the radius. Is that clear, beta? Yes or no?
Yes, sir, clear.
If only one could have been calculated, you will use that and draw your circle. So that takes care of our first sighting, last sighting, raising, dipping. So we have already covered PC by radar range, by vertical angle, by horizontal angle, by first, last, or raising, dipping. So these 4 methods we've already done. Now we come to the last one, PC by high altitude celestial observations. And that is the last for the day. Then we'll be done with the PC part also. Guys, yesterday we learned about celestial PLs. I'll not go into too much of details. If you want, I don't know whether Sunil will cover it or not. Celestial PLs. We learned how to draw the celestial PLs. But technically, I don't know if you remember from some earlier learning or not, these celestial PLs which you drew as straight lines yesterday, what are they? They are actually small part of a position circle. And what is that position circle? That position circle is the position circle drawn with the GP of the object as center GP of the celestial body is the center, and TZD in minutes as radius. So every celestial observation actually gives you a position circle. Now, what is the GP of a celestial object? Guys, if you have this surface of the earth, this is the center of the earth, and you have the celestial sphere. If you have any celestial object, if you bring this celestial object on the surface of the earth, where will it come? It will come and hit the surface of the earth on this line joining the center of the earth to the center of the object. And where it cuts the earth's surface, this will be the point where this body, if brought down, will become on the surface of the earth. This point is the geographical position of this celestial body. Okay. So when the celestial body is brought on the earth, it will be represented by its GP. This GP acts as the radius of that center of that circle, position circle. And the radius is the TZD. And what is TZD? We all know TZD is 90 minus true altitude. Yeah. Usually, if you see the altitude of the objects when you take sights is what? 30 degrees, 35 degrees, 40 degrees, 45 degrees, maybe 50 degrees, 55 degrees. So even if I take 50 degrees true altitude, TZD becomes 40 degrees, which is equal to 2400 miles. That means the radius of this circle will be 2400 nautical miles. So that means if with GP as the center and I draw a circle with huge radius, the curvature of the circle will be very, very less. Why? Because if you increase the radius, the curvature is decreasing. And now, if this is the azimuth of the object, then this small part of this circle can be taken as a straight line. And this is the PL we were drawing perpendicular to azimuth yesterday. So the PL that we were drawing was a small part of this position circle. Why? Because this position circle has huge radius, and when it has huge radius, its curvature is less. So over a small portion of it, the curvature can be ignored and the arc of that circle can be taken as a straight line. And that is what we were using as celestial PLs, which we discussed yesterday. But the problem starts if the altitude of the object is very high. If the altitude of the object is, say, let us say 89 degrees, let's say 45 minutes, if this is the true altitude. Now TZD becomes only 15 miles. If TZD becomes 15 miles, now I cannot draw this circle with huge radius. I have to draw with GP as the center and radius of only 15 miles. And when I draw a circle with 15 miles, the curvature does not become negligible. Curvature becomes appreciable. And now I cannot take a small part of it as a straight line. So when the altitude of a celestial body is very high and I solve the side, then I do not get a position line. I get a position circle. And that position circle is drawn with GP as the center and TZD as radius. Have you understood something? If you have not understood, then just remember that when the altitude of a celestial object is very high, it will not give you a position line, it will give you a position circle. The center of the position circle will be the GP of the object, and the radius of the circle will be the true zenith distance. Is that clear to everybody, guys? Clear, beta?
Yes, sir. Yes, sir.
Yes,
Now, this geographical position of yours is explained in your navigation book in chapter number 5. But I'll just give you how do we get the latitude and longitude of the geographical position of any celestial object? So lat long of GP. Guys, the latitude of the GP is always equal to declination of the celestial object. both in value and name. If declination is 50 degrees north, latitude of GP will be 50 degrees north. If declination is 25 degrees south, GP latitude will be 25 degrees south. What is the longitude of the GP? It depends on GHA. GHA is measured from 0 to 360, but longitudes are measured 0 to 180 east and 0 to 180 west. So now, if the GHA is less than 180 degrees, then longitude of GP is equal to the value of the GHA, and longitude will be named as west. But if the GHA is greater than 180, longitude cannot be greater than 180, guys. Then the longitude of the GP is equal to 360 minus GHA, and this longitude will become east. This is how you'll get the coordinates of the GP for plotting on the chart. Once you get the lat long of the GP, it can be plotted on the chart. That will become the center of the circle. You'll get the TZD. You'll open your compass equal to TZD as radius, and you can draw the position circle. So some part of it, if you are not able to connect here, I will not take you. I've actually tried explaining as much was relevant. Otherwise, little bit of it you might have to then just remember. Because I think it may be covered in navigation also, I'm not very sure. You see, whatever I have said is explained here. The celestial position lines that we learned in the last discussion are small part of position circle drawn with GP of the body as the center and TZD as radius. When observations do not involve high altitude, the TZD is reasonably large. So the straight line PLs plotted yesterday represent a small arc of that PC with the huge radius. In case the observation is a high altitude observation, TZD becomes small. In such cases, the radius of the PC becomes small, and then part of its arc cannot be considered as a straight line. In such cases, we plot a PC on the chart with GP of the celestial body as a center and TZD in minutes as the radius. How do we get the lat long of the GP? I have summed it up here again. The latitude of the GP is always equal to the declination of the celestial body. The longitude depends on GHA. If the GHA is less than 180, then GHA is the longitude and it is named west. If the GHA is greater than 180, then 360 minus GHA named east will be the longitude. So whatever I had explained in pen has been captured on this slide. And we'll see how this is put to use in one of the examples that follow. Star X with declination 51 degrees 21 minutes north. These declination and things have been chosen based on the latitude longitude scale of this chart in use, guys. So the declination of the star is 51 degrees 21 minutes north. GHA is 6 degrees 31 minutes. Was used for celestial observation. The true altitude was observed to be 89 degrees 54.6 minutes. Draw the vessel's position circle at the time of observation. Of course, from true altitude, we can get the TZD, GP of the star. The latitude will be equal to declination, that is 51 degrees 21 minutes north. And since the GHA is less than 180, this will be equal to the longitude named west. So these will be the coordinates of the G. The radius will be the TZD, that is 90 minus true altitude, 5.4 miles. Now we'll go to the chart and plot this position of the GP lat and long. This is the GP. This is 51 degrees, 29 minutes north. This is 6 degrees, 31 minutes west. This is the center of the circle. We open our compass 5.4 miles on the latitude scale. Here is the latitude scale. We open 5.4 miles. Put the compass at the GP and draw this circle. This is the position circle with GP as the center and TZD as radius. The radius is 5.4 miles. Is it clear to everybody, guys, how we can draw a PC for high altitude celestial observations?
Yes, sir.
Yes, sir.
So in case of high altitude celestial observations, you'll have to get the GP coordinates, plot the GP coordinates, and draw the circle with GP as the center and TZD in minutes as the radius. Okay, guys, this brings us to end of today's discussion. I will just share with you the video for what we have discussed today in case you feel the need. If you don't feel the need, it's perfectly fine. And please confirm the video.
Excuse me, sir.
Yeah, tell me.
सर जैसे आज का जो लेक्चर हुआ है ना सर, इसका वीडियोस क्या मतलब डाउनलोड मिल हो सकता है क्या, या इसका मतलब जस्ट जानकारी के लिए सर कि इफ यू वांट टू सोर्स
नहीं बेटा MS Team was becoming very expensive with the recording option, so I have not gone for that, but I have already shared the video with you ना. वीडियो लिंक भेजा था अभी तुम्हें इसका.
एक्चुअली कल का लेक्चर में सर मेरा इंटरनेट का इशू हो रहा था, तो मैं थोड़ा बहुत सारी चीजें मिस कर गया था.
एक मिनट उसमें कल PL का तो भेजा है तुम्हें मैंने. PL का कल वीडियो नहीं भेजा था तुम्हें लिंक?
सर वो मैं देखा नहीं सर एक्चुअली, सॉरी फॉर दैट.
तो फिर तुम देख ही नहीं रहे तो क्या करूं बता. ठीक है guys, I've just sent you the link for position circles. Please confirm it's received on the group. Okay, so those of you who need can watch it. And
yes sir, today we receive sir.
अबे कल का भी ऊपर जाना ग्रुप में मेरे भाई. Go scroll up in the group. It's there on the group.
है सर.
ओके. अब तुम आंख बंद करके बैठे रहोगे तो कैसे मिलेगा तुम्हें कुछ?
ओके सर.
Okay. Right, guys, then if you have any questions, please let me know, else we'll close the meeting for the day.
Sir, excuse, I have a doubt, sir.
Yeah, tell me.
Sir, regarding this GR and geographical range and PLR, if it is, we should not consider any daytime and nighttime. If it is given daytime, then this light won't be visible.
Beta, usually the questions are about light. Okay, daytime will be the lighthouse, right? But lighthouse visibility is, again, suppose daytime it does not make any sense, because I'll tell you one thing. Daytime sun is above your horizon. I gave you example, but if it is foggy, is the sun visible to you?
No, sir.
Okay, so if there is a lighthouse whose geographical range is 20 miles, let us say, and the visibility is only 80, say 10 miles, will you be able to see that light at 20 miles? Tell me.
No, not possible.
Not possible, no. So daytime, this concept actually does not make sense. Why? Because how visibility of the atmosphere is as much applicable during the day as it is applicable at night. Am I right?
Correct, sir.
Correct, beta?
Yes, sir. Yes, understood.
Okay, so what I'm trying to say is that if you can calculate both, please calculate both. If you're not able to calculate both for want of information, then calculate whatever you can and go ahead, use it. Okay?
Okay.
Okay, right. Okay, guys, then I'll take your leave. Can I close the meeting then, if everybody is aligned on it?
Yes, sir.
Okay, take care then.
Okay,
see you
sir.
tomorrow. See you tomorrow, 17:30, guys. Okay.
Yes, sir.